Hello and welcome, Woodrow Wilson friends, family, and students. This is Ms. Fields here, and I'm joining you tonight for our 11th episode of Math Toolbox. Tonight we're going to be discussing how to accurately multiply decimals and different strategies and organizers that you can use to be successful in practicing this skill. So typically whenever you encounter a decimal multiplication problem, it's going to be in the form of a word problem. So you're going to have to use strategies that we've used previously, such as UKT and different analysis techniques in order to determine the operation beforehand. So the problem states, Davon catches a fish that weighs 2 3/10 pounds. Sujal catches a fish that weighs 2.5 times as much as Davon's fish. How many pounds does Sujal's fish weigh? So what we're trying to determine right now is how much Sujal's fish weighs in comparison to Davon's fish. So we're going to be needing to use immediately a Foursquare. And we're also going to be needing to use different organizational techniques in multiplying decimals, which I'm going to explain in one sec, before we even begin the process. So there's a new element added to our UKT. Anytime we multiply a decimal, we're going to have this section here that says move decimal. So before you even begin the problem, you're going to identify in the decimals located in the problem, and that's 2 3/10 and 2 5/10. You're going to locate how many digits are located after the decimal. So in 2 3/10, we've got 1 digit after the decimal. In 2 5/10, we've got 1 digit after the decimal. So in total, we have 2 digits after the decimal. So we know that we will be moving our decimal 2 times when adding it back into the product. And that'll make more sense when we actually begin the problem. So after determining how many times we're moving our decimal, we're going to be looking at our units. And remember, units are usually found after the number or after the decimal. And in this case, our units are pounds and times. As we can see, these two units did not match up, so we know that we can eliminate addition and subtraction, So we need to move on to our keywords. So we're going to try and determine, is it multiplication or is it division? So times served as one of our units. In addition, it also is counted as a keyword. We know that when anything is something times as much as something else, we are multiplying it in comparison. So that times also serves as a key word. And immediately we know times means multiplication. However, just for the sake of moving through the whole UKT process, we can look back in the problem and we're going to see, are we trying to find the total or do we know the total? In looking at the question at the end, how many pounds does Sujal's fish weigh? We're trying to find that total. We don't know that total yet, so we're going to need to multiply in order to figure that out. Our next step in our Foursquare model, which is our organizational technique that we use for adding, subtracting, multiplying, and dividing decimals, is our box method. So up here, we removed our decimal from our numbers. So previously this was 2 3/10. Previously this was 2 5/10. We removed the decimal, so now they are represented as whole numbers. So 20 and 3 represent 23. 20 and 5 represent 25. Again, these are the numbers without the decimal inside of them. We removed it in order to multiply in an easier, more efficient way. So our first step whenever we're using box method is we look at our digits right here and we look and see how many zeros we're going to need to add into our box. So over here we've got 20 multiplied by 20. I see that there's 2 zeros that are going to be in that product. I see 20 times 3. There's 1 0 in that product. On our lower half with our digit 5, we multiply our digit 5 by 20. We're going to get 1 0. And when we multiply our digit 5 by 3, there's not going to be any zeros. So before we even begin our multiplication process, we add in our zeros, we separate our numbers using the distributive property into tens and ones, and then we begin our multiplication process. Again, whenever we multiply, this digit is multiplied, or this factor, is multiplied by the 20, and it's also multiplied by the 3. So when we multiply 2 and 2, because we already took the zeros out of there, we get 4. Our product in total, though, is 400. When we multiply 2 and 3, we get 6. However, there's a 0 in there, so our product is 60. When we multiply our 5 and our 20 and our 5 and our 13, remember we already have our 0 located in there, so we can multiply without that 0 present and then state the product. So 5 times 2 is 10, plus that 0, the product is 100. And last but not least, 3 times 5 is 15. Now again, with box method, this is the distributive property of multiplication. You're separating your numbers into tens and ones. We need to add all of these partial products into one product in order to get our final answer. So what we do when we organize is we extend these lines in order to make room for adding up our partial products. I stack the 400 and the 100 on top of each other because when we have place values, we make sure we line them up. Same with our 60 and our 15. Place values, line them up. We've got our ones with our ones, our tens with our tens, and same over here with our ones, tens, and hundreds. These are pretty easy partial products to add up. 400 plus 100 is 500. 60 plus 15 is 75. However, these are still partial products. 500 and 75 are just part of the product. So off to the side, I'm going to add up 500 plus 75. And my product is 575. However, this is not my final product because remember, we are multiplying decimals. So we need to add back in that decimal by moving it 2 times to the left. Now, a lot of fifth graders forget that our decimal in a whole number is always located right after the ones place. Now, if it says 2 times over here, we know that we need to move our decimal 2 times in order to find its proper placement. And that would leave our decimal in between digits 5 and 7, making our product 5 and 75 hundredths. Again, this is only the second step in our four-square model. We always use a second strategy when we're multiplying to ensure that we have an accurate answer, accurate product. So down here in this box, we're going to be using the standard algorithm. Again, we removed the decimals from this multiplication problem in order to simplify the process and make it more comprehensible. So this original multiplication problem was 2 and 3/10 times 2 and 5/10. We have 2 digits after the decimal place, so we know that we need to move that decimal 2 times in order to get a final decimal product. Again, with standard algorithm, we start by multiplying the ones place. We know 5 times 3 is 15. We drop down that 5 and we carry the 1. Our next step is we need to multiply our 2 by 5, which is 10, plus that carried 1, we get 11. So our product between those two numbers is 115. Our third step is purely organizational. We're taking away that carried 1 and we're adding in a 0 placeholder because we know that we're multiplying these two factors by 20 instead of by just 2. 2 times 3 is 6. And then 2 times 2 is 4. Now that gives us 115 plus 460. Again, we need to make sure that our place values are perfectly lined up in order to ensure that we get an accurate sum. And we need to also make sure that we know that these are partial products and they need to be added together in order to get the final product. Again, this is a pretty simple addition problem. 5 plus 0 is 5, 6 plus 1 is 7, 1 plus 4 is 5. However, this 575 is not the final product. We need to make sure to go back to how many times you move the decimal, which is 2 times. Again, that decimal in a whole number is located right after the ones place. And we're going to move it 2 times in between the 5 and the 7. And that gives us a final product of 5 and 75 hundredths. So I need to look back to my box method. I see that my products both match, meaning that I accurately multiplied both of these numbers in 2 different strategies, which leaves me to reflect and go back to my original word problem to find out what I'm answering. So I'm determining how many pounds does Sujal's fish weigh. Now, in other problems, you're going to be answering the problem at the end. It's the sentence with the question mark. That's what you're going to be stating your solution about. And that's why I highlighted this right here. In any other word problem, it's usually a question posed at the end of the word problem. That being said, in answering the problem, I can say that Sujal's fish weighs 5 pounds, and that is 2.5 times more than Devon's fish. Thank you so much for joining me tonight for our 11th episode of Math Toolbox. Accurately multiplying decimals combines a lot of skills that we've learned previously in the class. So if you're a little stuck on UKT, if you're stuck on box method, standard algorithm, please go back and review those videos in order to sharpen up your skills. If you have any questions, feel free to ask me in class, and I can't wait to see you guys on Monday morning. Have a great weekend.